In VR, expressing spatial intent still means thinking in commands, parameters, or coordinates. People do not naturally communicate space that way. Instead, they speak and gesture relationally. Put it on top of that. Rotate it to face me. Push them against the corner. We introduce reference-based manipulation, a framework and pipeline that treats the reference as the construct underlying spatial intent in VR. Our research is inspired and grounded by spatial cognition theories. Based on the theories, we set up to first observe the natural behavior patterns in how users use speech and gestures to specify spatial intents for manipulating objects in VR. In a Wizard of Oz study, participants stood in a tracked space wearing a Quest 3 and worked through 3 tasks: a guided practice with 3 cubes, a structured block-building task with a reference image, and a free-form creation scene with semantically labeled assets. They were told the system would interpret any speech and gesture they produced. Behind the scenes, a hidden researcher operated Wizver, a custom toolkit we built to interpret each participant's speech and gesture in real time. According to participants' first-person view, the wizard turned natural commands into scene changes through object selection and button control for placement, duplication, alignment, and appearance changes, etc. From our findings, we formulate a framework of reference construction. Every spatial reference instruction consists of 3 components: a source, an anchor, and a frame. Sometimes one instruction involves multiple or implicit references. Thus, we map out a design space of reference compositional strategies organized along complexity and explicitness. In addition, we observed how participants combined speech and gestures to resolve implicity in referential expression, which exists in more than 3/4 of all the expressions we collected. Based on this framework, we built the RBM pipeline, a 3-stage system that interprets references from multimodal instructions. Perception turns the live scene and the user's speech, gesture, and viewpoint into queryable data. Reference analysis uses an LLM, grounded in example references from our study, to resolve each instruction into source, anchor, frame. Execution retrieves the relevant attributes, computes the transformation, and applies it, carrying state forward so iterative and progressive references work across turns. Next, we demonstrate a set of example interaction techniques built on RBM pipeline.
Make these earth blocks backside against the wall. Let the sand block come in front of me. Shrink the windmill to half. Put this on top of that. Rotate it to face me. Push them against the corner. Return to its original position.
We hope reference-based manipulation offers both a conceptual foundation and a practical starting point for systems that understand how people naturally communicate spatial intent.